Artificial intelligence and machine learning have been incorporated in our daily life in the modern world, and one such important tool is our emails. Our emails have the capability to classify the messages that they receive as either spam or ham. Today, I'm going to show you how you can be able to create a machine learning algorithm that can be able to classify your emails or your messages as either spam or ham. Before we proceed, be sure to give us a like, subscribe to our channel, and also share this content with your friends. And if you have any comment that you'd like to share with us, put it in the comment section. We are sure to respond to your comments. Thank you. Let's now proceed. To do so, I'm going to use a Python programming language. I'm also going to use Google Colab and a dataset that I have obtained from Kaggle repository. I'm going to attach the link to the dataset as well as the link to the GitHub repository containing this code. Now, to start with, I've uploaded my dataset to Google Drive so that I can be able to work with it much easier. So this is my dataset. It is known as spam.csv. So I'll come to my Colab and I write this code to mount my Google Drive. So just run this code and you give your Google Drive or you give your Colab all the access that it is going to ask you to give it. In my case, it already has access, so that's why it has told me that Drive is already mounted. In your case, you may need to give it privileges so that it can be able to access your data set. From there, we import the libraries that we need. We start with pandas. Pandas is mainly used to load our data set. It is also used when you want to manipulate our data set by creating data frames and also checking for other factors in our data set, such as the size of our data set, checking for null values, and other manipulations that we may desire under data pre-processing. Then we import count vectorizer. Now, our data set is form of text, but remember, machine learning algorithms, they are mathematical models, and therefore, they usually understand data, or they usually understand everything in numerical terms or in numerical values, though we need count vectorizer so that we can be able to convert our data from text to numeric values. Then we import the train test split. This one, we are going to use it to divide our data into a training set and a testing set. We are using supervised learning, and therefore we expect our data set to have both training instances as well as labels. And in this case, our data set can be put in the form of X and Y, where X is the training instances or the message that we want to train with, and Y represent the labels. Therefore, we can use quite a number of algorithms here. We can decide to use algorithms such as support vector machine. We can also decide to use decision trees. We can also use random forest. We can also use other algorithms such as naive Bayes. And if the dataset is big enough, we can also be able to use artificial neural network. For this case, I have decided to go with naive Bayes. This is an algorithm that was proposed by the Reverend Thomas Bayes, and it uses probability theory in order for it to be able to classify our messages as either spam or ham. Then I'm going to import the metrics that we are going to use. And in this case, we are going to use the accuracy score and a classification report. When you're dealing with a classical machine learning algorithm, the classification report contains things such as precision, recall, F1 score, and others. So we run this particular cell to import all our libraries. From there, we go to the second cell. We don't necessarily need this line. You can omit it because you have already imported the libraries. We define our file path. So how do you get this file path? Once you have mounted your drive, come and click on this folder like that. Then navigate. So once you click on it, this is what you're going to get. Click on G drive, go to my drive, go to where you have your data set, and now click on these 4 vertical dots, copy path. And once you copy path, you come and you paste it there. And remember, you need to put it in quotation marks. Then we load the data set, we create a data frame, and we use read.tsv, which is a function inside pandas for loading our data set. Then we display the first 5 rows of our data set by using df.head, which is dataframe.head. Now, if you want to display more than 5 rows, you can be able to put the number of rows that you want to display inside here. For instance, if I change this one to 10, it's going to display the first 10 rows. If you want to display the last rows, instead of using head, you can use tail. You can be able to use tail to achieve that objective. Now let's understand what is contained in our data set. Here we have the indexing. This one is automatically generated for us, so don't worry so much about it. Then we have V1, which contains our Y or our label. And in this case, we have two types of labels. We have ham and we have spam. Then we have V2, which contains our X or the message. And in this case, we have quite a lot of text here that we are going to use. We have other labels here that are called unnamed 2, unnamed 3, unnamed 4. So this is just noise in our data. We need to remove these labels and remain with only V1 and V2. So we start by first removing the two labels that are, or the other, I said three labels that are unwanted, or three columns that are unwanted, and only remain with V1 and V2. So we come here and we define the columns that we're interested in. And after defining the columns that we're interested in, we also go ahead and we change their column names from V1 and V2 to what we have here now, the label and the message. And after that, we convert this column known as labels, which was initially V1, into binary, that is 0 and 1. If you look at it, we have two types of labels. We have ham and spam. Now, we want ham to be represented as 0 and spam to be represented as 1. So we use this line of code, which is a data frame manipulation, to convert it from 0 to 1. So what you do is that you come here and you define your data frame, you pick the data frame. In your data frame, you pick the column known as labels, and then you do what is known as mapping, and you map ham to 0 and spam to 1. Then from there, we print the head or the first 5 rows in our data set, and this is how they look like. Now we can see the column names have changed. This one is now label, this one is message. The other columns that were unwanted or the noise in our data set has been deleted. And now also the Y's have changed. Now here we have 0 and 1 instead of ham and spam. Now that our data set is quite clean, we can now go ahead and split it into a training set and a testing set. To do so, we are going to use the train test split. And here we are going to define X-train, which will contain all instances of the messages that are going to the training set. X-test, which will contain all instances of the message that will go to the X-test. Y-train, which will contain the corresponding labels of X-train. That is, if a message, for example, let's say, for example, this index 4 was taken to the X-train, then also its label, the corresponding label, should also be taken to the X-train. And the same happens for Y-test. Now, our splitting size is going to be 0.2, in which case 20% will go to the testing size, or the testing set rather, whereas 80% will go to the training set. We have set a random state of 42 to guarantee consistency in terms of the results that we are going to get, and also it defines the value at which you want our data set to be randomized. Then we can be able to print the sizes of the training set and the testing set, and we can see that we have 4,457 instances for the training size and 1,115 instances for the testing size. That is quite a small data set. Therefore, we cannot be able to use it with you cannot be able to use neural networks in it because it doesn't have a lot of complexity. And if you decide to use neural networks with that small data set, you may end up achieving low performance because of the way neural networks have to weight their neurons and so on. So let's just use naive bias for it. Now, I had mentioned earlier that machine learning algorithms, they usually understand everything in numerical values. And since our text here or our message here is still in text format, we need to convert it to numeric values. To do so, we use count vectorizer. And count vectorizer is a method that is usually found in scikit-learn, and it usually converts text by following a bag of word approach. So in this case, we are going to pass our X-train to the count vectorizer and create a new variable known as X-train underscore vec, which is the vectorized version of X-train, and do the same for X-test to get the vectorized version of the X-test. After doing so, we now go ahead and we call our algorithm, or we define our algorithm and we train it. So to define our algorithm, we create a variable known as model, and we call multinomial naive bias. Remember, we had imported this algorithm when we were importing the libraries earlier, but you can still import it here, doesn't cause any harm. But if you don't want to have so many lines of code, you can just retain the import that you had initially. Then we use model.fit. This is a method that is used for training a machine learning algorithm, whether you are using scikit-learn or you're using TensorFlow. Remember, scikit-learn is the primary framework that is used when you're dealing with classical machine learning algorithms. But when you have to deal with neural networks and deep learning, then you have two options. You can use either TensorFlow or PyTorch. I'm not assuming that there aren't others that can be used for deep learning, but I'm just highlighting the most popular ones. So the same method, model.fit, is also used in TensorFlow. But if you are to use PyTorch, then you need to create a training loop and a testing loop. So let's go ahead and run these codes. So we run that one. We come here and we run this one for vectorization. We come here and we call our model, and you can see that the model has been created. The next order of business is to go ahead and predict. So we create a variable known as ypred, which is going to contain the predicted value of y. And in this case, what have we done? When we split the data set into a training set and a testing set, is that the testing set went together with the labels. Now, what we want is that we want to take the x values, that is the independent variable values or the messages from the testing set. We pass it through our algorithm. Then our algorithm predicts the labels for that particular messages in the testing set. Then we compare the labels that the algorithm has given against the ground truth, which is the actual labels, and then from there we're able to get our classification report. So that is exactly what we are doing here, and that's why you see we are passing the x test underscore vec. We are not passing the y test. Now we go to evaluating the model, and in this case, we print the accuracy score. And if you look at the accuracy score, we are comparing the y test and the y pred. And in this case, the y test contains the actual labels, y pred contains the predicted labels, and we want to output our values in a form of two decimal points or two floating points. Then we print our classification report, still considering the y test and y prediction. And once we run it, we can be able to see that we have this particular display. We have achieved an accuracy of 0.98, which is equivalent to 98%. 98% is quite a good accuracy. We can't complain much about it. Then over here, we have our classification report. We have a precision for 0 and 1, 0 representing the harm and 1 representing the spam. With classical machine learning classification report, they usually do these classification reports for each of the classes that you have. So you can see that the variance is not so much between the harm and spam, which it clearly indicates that our data set was not imbalanced. But of interest here is the macro average and weighted average. When you talk about macro average, here it considers the average of the precision for both harm and spam without necessarily considering whether there was any kind of biasness or whether there was any kind of class imbalance. Weighted average, on the other hand, it considers the aspect of class imbalance. So therefore, weighted average becomes the best factor to use when you want to evaluate the overall position of the performance of the model, taking into consideration both the spam and the harm, or both the 0 and the 1 class. And you can see we have achieved a weighted average of 0.98, which is quite good. Thank you for watching our video this far. We appreciate your presence. We hope that you're going to give us a subscribe. We're also going to give us a like, a comment, and you're also going to share this content with your friends so that they can also benefit from what we are developing. And be sure to check also our other videos in this channel. They are quite informative and they are quite educative. Thank you. See you next time.